Hello everyone, I'm sure you are doing awesome. In this video, we are going to talk about using Spring Boot, how we can talk to NoSQL databases. So the details of the NoSQL databases and the varieties of it are already covered in an earlier video under the system design series. So if you want to dig deeper into that, that's a perfect place. All the type of the basic NoSQL databases are being covered there. However, that is not a hard prerequisite, but it would be a very good or nice to have sort of a prerequisite, I would say. Now, coming to NoSQL. So, when we are terming a certain database as a NoSQL, behind the scene, we can actually query the data. It is not that like through query language we cannot access the data. So when we say NoSQL, it's kind of a very bad naming. When we say NoSQL, we basically mean that the relational constraints are not enforced here. So for example, like in case of RDBMS, as we have two tables and they have a certain foreign key constraints, those sort of constraints across the NoSQL databases are not particularly maintained until unless we enforce it by ourselves. And NoSQL also have multiple kind of databases. So this all family of databases, like which are the document DB, if we say, through document DB we store the data in a semi-structured JSON sort of a document. Okay, and the one of the example is can be MongoDB. Coming to the next type, that is KV pair or the key value pair. Like there will be a unique key and there will be associated value. So the associated value can be a string or a JSON or even a binary large object. So in that key and JSON sort of a thing, sort of you can think. And the example would be like the AWS DynamoDB or even the Cosmos DB in Azure. That is a great key value pair database. Then comes the columnar family. So column family is data in column family databases are stored in columns instead of rows. It is a little difficult to visualize, but uh, like it has a completely different use case. That is what I have covered in very detail in one of my system design series database. Uh, So the database is like where we store our very high write throughput logs, or any cases like the clickstream data. They generally have a column family databases. Okay. And the examples would be like ClickHouse, as I was telling, like it is storing the clickstream data, like the amount of clicks that are happening, or even the way the mouse is being hovering across the screen. Those sort of things ClickHouse can store, or even AWS Redshift is one of the great example for this. And then there comes the graph databases. The graph database is you can think of any social media like Facebook or Instagram. So when it gives you the things like people you may know, it try to find out one of the nearest neighbor in some k distances. So databases like Neo4j are the perfect use cases for that. Now probably by this time you understand that this many number of databases are coming under the NoSQL, whereas when we are talking about RDBMS is only a single type of relational database which we meant. So NoSQL is always a family of database, and there is not a single definition through which we can explain this. So in this video, we are going to take the example of Cassandra and little bit around MongoDB. So Cassandra is something that we are going to take up the internals of Cassandra, plus we are going to implement it in our Spring Boot application. Simple get, post, put, delete, like CRUD operation, create, retrieval, update and delete. Those operations how we can do, plus also little bit of MongoDB we will cover, but it will be your task to implement the whole MongoDB into your Spring Boot application. So now let's jump on to the Cassandra. So in case we have a simple table like this, which is holding some kind of a medical information, what generally we will represent in our RDBMS. Let's see that. So in our RDBMS, particularly suppose SQL Server Oracle, in all of the places, this thing will at first be expressed as a patient table. Okay, and alongside patient table, if I have to take this record and try to analyze it a little more, so we have this patient data. Okay, so we have a patient ID, patient name, and alongside this, we also have the doctor's name associated with it, right? So patient ID, patient name, appointment ID, and some of the appointment details, plus the doctor's details, and alongside that, also some of the information about what is there in the prescriptions, okay, or what is there in the notes of the doctor. So if I have to just see how this record will be represented in a traditional RDBMS, it will come something like this. Like there will be a patient table and there will be doctor's table. There will be appointment table, and also there will be something like a medical records, some table like this. So if I have to just compare how it would be, so patient table would ideally take this two, appointment will take this three, uh, doctor's table will be about this doctor, and the medical record would be, it will be taking these two, diagnosis and treatment. So when we want to get this data, how we will get, we will do some sort of a join mechanism, and after the joining we will get the data, and it is a very standard, if I have to like rate this approach, this is a very good in terms of the storage efficiency, right? Like I'm not storing any duplicate data anywhere. If I see this thing carefully, look, the patient data is only in the patient table, the appointment data is only in the appointment table, the doctor data will be in the doctor table, and the medical record data will be in the medical records table. Now, this is what we call is good in terms of storage and normalized. So again, normalized means like all the data are being separated properly. In case of Cassandra, now coming back to our today's agenda on the Cassandra, the mindset is completely different. The mindset, how we are going to get this data or query this data, that will be our primary goal. So the first thing is, it is a completely denormalized DB, Cassandra. Okay. And the next part is, we ignore the normalization. Instead, we ask what queries I want to be super fast in my DB. Okay. So if I ask you over here, like what are the basic query for a medical record system that you are looking at? So the first thing that definitely would come to your mind is like get all the appointments for a patient. Like suppose there is a patient app you are trying to build, and his upcoming appointment, based on those upcoming appointment, giving them some suggestions or giving them push notification, those will be your primary data points and the business actions, right? So this is a very important thing, like getting all the appointments for a patients. And then will be get like for your admin, suppose get all the appointment for a specific date. Again, this is also very important, that all the appointments, like suppose for your admin you are building a web dashboard, they need to see all the appointment in a single place, right? So all the appointment in a specific date they need to see. Okay. So also like get a patient's uh, patient's record, like all the records. If I have to say, a patient might be suppose you are running a hospital, a patient might be looking for all the records. So these are the very basic things that I could think of Like this is one kind of a query, this is one kind of a query, and this is one kind of a query. Now based on these queries, how can we how can we uh, like design our database? That is one of the main problem that Cassandra solves. Okay, and we will gradually, when we go ahead, we will see how powerful Cassandra is, but this is the very basic premise of it. Now suppose the first table that we were talking about, how would the table look like? The table 1 is appointment by patient, and this thing again we are going to completely implement in our code as well. So in the appointment by patient, we are going to serve some kind of a query like select star from appointment where the patient ID is some XYZ. So this is going to be my query. Okay, and there will be a basic schema that we will be writing. So that schema is known as CQL. And as you have guessed correctly, CQL is nothing but Cassandra query language. And in CQL, we are going to create a table. So it is quite it is quite similar to our the actual create table statement that you might have learned in your RDBMS days. So it is not much different than this, but there will be two additional things will be there. One is the partition key and another one is the clustering column. So let's understand what is a partition key and what is a clustering column. So in case of partition key, over here, our partition key we are taking as a patient ID, and it is completely different from the primary key. Primary key in RDBMS, it determines that it will be a unique record. So whenever we are marking something as a primary key, that becomes a unique record in our database in RDBMS, right? But here we do not have a concept of primary key. Why? Because when we are flattening or denormalizing the data, if you see over here, the patient IDs are kind of same, but their rest of the records like the appointment date is different, their doctors are different. So uh, a partition key doesn't really tell you that this patient ID or the key that we are defining is going to be a unique one. Rather, it helps you in distributed and the scaled system. How? It makes sure that all the data for that one patient ID or one key, they live in the same node. So if you go into the distributed route, suppose you are running one of the biggest hospital chain in India, and there are so many patient influx and there are so many records of the patients you need to store. You cannot really store all the patient record in a single database, so you have to go in a distributed manner. And the moment you go into the distributed manner, Cassandra would make sure that this particular patient always lives in the same node or the same machine in where no matter how you have scaled the node that you have defined, or the machine if I say, that will be uh, mm, that will be having that unique set of patients together. Now why this is important? Because the moment I start querying, if it is a cross shard or a cross distributed query, let me make it clear. If the moment any query become a distributed query across the nodes or shards. Okay, so nodes means like as you are dividing your data into different databases in different geographical boundaries or different machines, suppose. So those things are being known as nodes, and the moment you need to query two different node and bring the data, so just think through like this, that you have two databases, and from this two database you have to build a query, and then again you need to go to and fro like this two database, and then you need to bring back the data from bring back the data and do a aggregation of it. So in this whole process, you probably understand that how difficult or how latency sensitive this whole process becomes. So that thing is saved by the this uniqueness of the partition key, where it promises that all data from one patient lives in the same node. Now the next thing come as a clustering column. So clustering columns gives you a very unique feature of ordering by default. So when you have this kind of things like the appointment date or the appointment time, you always need to access the appointment date or the appointment time which is the latest one, right? That will be your point of concern. So rows sorted chronologically within the partition. This is the this is the advantage it gives, that in this node it makes sure that all the rows are being sorted by appointment date and the appointment time. So if we do a technical analysis of it, we will see that this is a quite efficient in terms of the querying. It will be definitely efficient because in one partition read per patient, we will get all the data, and also the data is sorted so the appointments are completely returned in a timely manner, so or in a orderly manner, so we get our latest data as per our data model requirements. But the problem that will happen is the data is duplicated, right? So patient name, as you can see, it is being repeated on every appointment, whereas if I had to go with a RDBMS data, okay, like as we were talking about the RDBMS in the patient table, for a single patient, only one time the data will be there, like P001 and the Alice Smith, there will be a single record, and through the foreign key, it will be aggregated to the appointments, right? So that is the case of RDBMS, but in our case, we have the same record in multiple places, and this is causing a problem of data duplication or the storage duplication. So this is kind of a like a trade-offs that we have to live with if we are going with a Cassandra. So let's take example of another table which probably would give us a little bit more idea. So when we are going with the appointment by date, so the previous one that we did was appointment by patient. Now appointment by date. This is what we are building for our, suppose for our admin dashboard we are building, like our admin or for the reception desk, they need this data, right? So the purpose is serving the Q2, and the query is select star from appointment where certain appointment date is there. So the moment we see this where condition, okay, the moment we see this where condition, one thing is clear, that this appointment date, this is going to be my partition key, because like whenever these dashboards are coming, probably I will be as a receptionist or I'll be as an admin will only be concentrating upon today's appointments. So that's the most important data for me. So the single date appointments has to be grouped together. Second thing is the clustering, that is the appointment time, then the appointment ID, to ensure the uniqueness. So I need the data in a decreasing or a increasing order by date. So the clustering will be done by the appointment time and by then further by appointment ID to ensure the basic uniqueness of the record. So in this way, we are going to design this table of us, and the advantage of course is, like as you can see, it is a fast retrieval appointments, and the same appointment will appear in uh, both of this table, like appointment by patient and this appointment by date. So that is the disadvantage of it. So I hope after looking into these two tables, you got the idea that why Cassandra is being used instead of the relational database. It's a completely mindset shift, and we keep our data in a denormalized way, as we saw. And for this denormalized DB, how we are making sure that the datas are being grouped together is through the partition key and the clustering columns. So now let's take some let's get into some other fundamentals of it. We have to understand about the partition key at first. So partition key, although we discussed, so but I will just emphasize it again, that it makes sure that all the same partition key data goes into the same node. And how it determines that, and like which node stores the data, it determines that by using a hash based system. Like for that particular record, whatever the hash comes, all those hashes will go into a certain into a certain node, and all the data in that partition will be stored together, and they must fit in one node. So again, like there we will go into a little bit further internal if we start on giving into the node, but just understand this thing very clearly. And the clustering of the columns define a unique thing of ordering. So it is define the sort order of the data. Now the uh, main takeaway among this is we cannot query without the full partition key. So for example, if we try to query something like this will not work. Like when I do, I will just break it down a little bit for better visibility, that I am writing a select query. Okay, so this select start from appointment by patient, where appointment date is something, this completely fails. Why? It will fail because this guy would fail because there is no patient ID or the partition key has been mentioned. Because how the database would query this, it has to go through all the different partitions, right? In all the different nodes, there can be so many data. So whenever making a query like this, our partition key is always required. And this is this is also like if I mention my patient ID, and this also helps in the range query sort of a thing. And this is perfect for like huge distributed system databases. So why it works with distributed system is, first of all, there is no join. So cross node, I don't have to go, right? I don't have to go. So no joins is a very great advantage that Cassandra provides. And also the latency is quite predictable. Like if you see, for partition there will be a certain lookup. Like if I have if I need to just find out in which partition my data is, so there will be, like in terms of the time complexity, there will be O1 is the lookup time, and and the main search will be just a sequential search, because my data is totally sorted. So if I have a certain key in the place, I will be able to find it sequentially, or any other further algorithm if I want to apply on top of it, but it will not be more than O of n for any record, right? So here these are the advantages of course we are getting, but we saw that it is taking some extra storage. But it is not a problem in the modern computing. Why? Because storage is now super cheap. So like if you are using commodity hard disk drives, then this kind of storages are really cheap. We do not have to worry a lot about it. So with this, the like the extra storage is although not a problem, but there are some other technical issues are there which I am not going into the detail, but just on a very surface level understand that the coordination where exactly the data will go, that is one of the expensive part of this whole architecture of Cassandra. Okay, so we are right now trading disk space and some of the coordination complexities for the speed and simplicity. End of the day, it is very very fast, and it is very simple, like the way the data is being spread across the different tables. But again, the problem is like with duplicacy, you need to keep on maintaining in different tables. If you forget to enter your data into one table, suppose there is a certain billing table you have created, then probably in your revenue it will not show up. So this sort of problems are of course there if we are if we are using Cassandra. So now let's do a final comparative analysis with SQL Server. So with SQL Server, if I compare, the data model is completely normalized, whereas in Cassandra we saw it denormalized, and we kind of got an idea what is the difference between the normalization and the denormalization, right? Then there is storage. In the storage, SQL Server, there is very minimal duplication, but in Cassandra, no matter how many like there is no exact way to connect two tables, so there is always that risk of very high duplication. And there are the query flexibility is like we can do any query with join, whereas for Cassandra it is a pre-designed queries. And when we go into our application implementation, we will see that how these pre-designed queries we can write. Then there comes things like scalability. It is vertical or little complex in the sharding, whereas scalability is very very easy with the Cassandra. So Discord was there in Cassandra for good amount of time. Later they, I think, shifted to SilerDB probably with all their chat application. But if a certain system like Discord could support that, probably across the world, any high rate system, for any high rate system, Cassandra is quite good. And in terms of the consistency, it is very strong. And whereas this is a kind of a eventual consistency, like in one node, though you have made a change, the corresponding node where you are putting the data into, it might take some time to get the data into there. Whereas here, being a strong consistency candidate, if a certain part of your transaction fails, it will completely roll back the whole transaction, right? So like if I have to conclude the design principle of Cassandra, you model your tables after your screens or API endpoint. So you go into a screen and you make sure that this particular screen should get the query in a single go and in this manner. So suppose for your patient dashboard, as we were talking about the patient dashboard or a mobile app, like the moment the patient launches the application, the after the launch screen, whatever the home page that comes, it need to have all the appointments by by that particular patient, right? So if you are building a patient dashboard or a daily scheduler sort of a thing, like appointments by date or a medical events by patient, a complete medical timeline, so then Cassandra is perfect for you. So in case you understood till this point, let's try to brainstorm around this problem statement. Okay, so the checkpoint question is, why can't you efficiently query find all appointment on a given date? Like we discussed that this particular query will fail. So why it will fail? The answer is simple, because the query requires scanning all the partitions. Okay, since you don't know which patients have appointment that day, and Cassandra is optimized for queries that provide a partition key within and searching within that node. So we have to, for this we have to, the best answer would be like we have to create a appointments by date table. It can be a very well derived table, but using this table we would get the data that we wanted, all the appointments of a given date. Okay, let's take a look into another application. So you need to query that get the 10 most recent medical events for patient X, and your table has a certain primary key with a descending clustering. Now, what would be the time complexity? This is going to be an interesting thing. Before looking into the answer, please pause the video and try to think through. So yeah, if you are able to understand, like initially that we discussed, that O1 is our lookup time, right? So O1 would be our partition lookup time, and then through the DESC clustering, we in log n complexity for retrieving the 10 rows practically in a constant time. Okay, and the data is already sorted on the disk, so that is why this only O log n time it is taking. And if I have to compare it with the SQL server, we might need a index scan or sort operation. So whereas in the SQL server it will be O n log n. So right now we see that with the O1 plus O log n, we are able to achieve the main extraction of data. That is why it is way better than O n log n. And again, if it is not indexed, then only it will take O n log n. This indexing and the other funda we have discussed in our database internal system design series. So if you have any doubt regarding that, probably that would be a good place to look into. So now let's start with a demo application. In that particular demo application, we are going to implement like how Cassandra works with Spring Data. We are going to explore end to end all the request flow and how exactly the Cassandra as a database works with this, and what are the internals workflow, and how we can get a simple request response completely traced from starting to end. All these things we will explore through this demo. So how are we going to install Cassandra? So we are going to use Docker, and using Docker, we are going to install through the Docker Compose our Cassandra. So what exactly a Docker Compose is, there are some other concepts are involved there of the containerization, but just understand this thing. Using Docker, instead of installing Cassandra directly, what we can do is we can run the official Cassandra container that already has everything configured. And in this way, we can skip the complex and the conflict of the other tools which you might have during the installation. And the important part is this file of Docker Compose. And this Docker Compose, what it will do is it basically tells you that download the standard Cassandra. For our case, we are going to take the 4.1 image from the internet and start it. And we are going to expose the port 9042 so our Java app can talk to it. And we are going to give it a name. So now let's go into this and see the Docker Compose on a very high level. And we are going to start our Docker instance of Cassandra. So this is the application in the screen that you are able to see, right? So in this application, I already have a complete setup guide presented. And in this setup guide, as you can see, like what I did, I just run the Docker Compose up -d. And what it did, it automatically checked if it already has a Cassandra image. If not, it downloads it from the Docker Hub. Like an Docker Hub is nothing but an app store for the containers, and it start a new container using that image, and it runs it into the background. Like the moment I mark it as a -d, that means it will be in a detached mode. So under a minute, you have a real working Cassandra database, no manual installation, no version, no conflicts. So I hope now this part is totally clear to you, and I'm going to again take you through a little bit into the Docker Compose YAML that we have. I will just give you a very basic walkthrough. So only prerequisite is you need to have your Docker desktop in case you are having Windows. So if you have the basic Docker setup, you can run it. So this is my Docker Compose YAML. And again, like if you have any issue setting it up, like I have a complete setup guide ready for you, setup and application walkthrough, which I will just take you through. So through that setup guide, you could very easily set up your complete Cassandra from end to end. What are the things you need to do? Everything has been written there. Now, coming back to our Docker Compose. Here, let's have a very basic walkthrough of what each of this component tells. So this is nothing but the Docker Compose format version in our YAML file we are mentioning. And what is the service? It defines the name of the service, and Cassandra 4.1 tells that you need to pull the official Cassandra 4.1 image from the Docker Hub. So Docker Hub, again, as we said, it is like downloading the app from a store. Nothing further complicated than that. And the container name, when we are going to run it, we are going to run it as a hospital Cassandra because it is a simple medical healthcare system that we are trying to build. And in which port you are going to expose, so that you can refer it very you can refer it the moment you want to access your Cassandra into. This is how your Java app is going to connect to Cassandra through this port. Okay. And there are some other environment like the cluster name. There is the data center. The data center is basically has to match with the Spring Boot app, whatever it expects. This is a little out of the scope stuff, but still I would say that like probably you got the idea what it is doing. And the volume is basically it parses the data outside the container using a Docker managed volume called container Cassandra data. And what is the advantage of it? So even if you delete the container or you stop the container, this particular uh, container volume which was persisting the data, it will be the outside the Docker managed platform, right? So your records are not lost. And health check is also a very interesting thing. In every 30 seconds the Docker is going to run this SQL sh. So this is basically the shell hit for the Cassandra, and it will keep on checking whether Cassandra is truly ready. If it fails for 5 times, Docker marks the container as unhealthy and it is no further useful for debugging. And in the bottom that you see the volumes, it is basically the declares the name, and so that Docker basically knows that from here it is going to take the data. So now you already see the structure of it. In case I want to give you a very high level architectural idea how it is going behind the scene is, we are going to send a HTTP request. So we will use Swagger. In our last project also we use Swagger, right? So Swagger UI, we are going to produce a HTTP request, and that HTTP request would further go to our Spring Boot applications REST layer. So in our case, it is our patient controller. So if I have to take you in my application, like where it will first hit whenever a REST request comes in after any HTTP request is being served, it will at first come into this patient controller. And of course, like that this Spring Boot application is basically our application startup entry point, but this is our execution entry point whenever a request is being served. So after this, what would happen is the data would go to like various endpoint that we'll be having, like the patient events and stuff. Then from there it is going to hit to our Spring Data Cassandra template. That is where the main entity to row conversation will happen. So this is where the we call it a Cassandra template template mapping. We will see the whole thing in action. So in the Cassandra template mapping, the entity to row conversation will happen. Okay, so from here we are going to do the entity to row conversation conversion, sorry, entity to row conversion. And after that it will be passed to our repository layer. And from repository layer, when we see, it will go to the different repository. Like for the patient repository there will be one particular Cassandra repository we are going to have. For medical event repository there will be another. And so from after those repository layer, it is going to go into the configuration layer, and there the main Cassandra config would go to something called the data stacks. And if these terms are appearing a little alien to you, don't worry. The reason I'm writing all these things, I'm going to explain it to you one by one. And this data stacks is the stuff that will actually fire the SQL query. So when I say SQL, it is not SQL, it is actual SQL, that is the Cassandra queries. So this SQL query will hit our Docker instance, the one that we actually just wrote, and there will be like one table of patients, and there will be one table of medical events. So these are the things that will be there. So it is nothing but the same example that we have been taking so far. So this is from top to bottom, this is how it looks like. Now let's do a small revision what we have just learned, because probably it has been too much of a information for you. So at first it comes to the patient, this patient controller. So patient controller is nothing but like it is the REST controller layer. It defines the API endpoints like creating a patient or adding a medical event. And below that, this part is basically your template mapping, and the entity row conversation comes under your business logic. Okay. And in the business logic, what happens? The Cassandra rows using Spring Data Typesafe codex. The collections are correctly serialized here, and then it will be passed to the repository layer. Okay. And to explain it further, let's take this object example. So what this business and the data mapping would do is Spring will validate the object. It will check whether this date of birth is correct or not, and it prepares the data for Cassandra, like it will convert into a local date. And then there are things like the EVUID, for example. Often we have a unique ID for the patient or the unique ID for the record. So those EVUIDs and the other details for the Cassandra will be generated here. So after coming to the repository layer, so here all the EVUID generation and everything is being done. So after coming to the repository layer, what would happen is from the repository layer, we are going to fire something like a patient repository dot save. And under the hood, Spring Data translate this into a like a SQL statement using the entity mappings like the table, primary key, everything that you have mentioned in the actual mapping. So we will come to the mapping while we debug through the application. And then in the configuration layer, Cassandra config ensure that the session connect to the right key space. Like there can be multiple databases, right? So the database, the data center where the data actually resides, all these things, and the connection config like data center, connection connection session, all these things are being controlled on this. Now comes the DataStax Java driver. So this Java driver, it takes the actual SQL query, okay, and this SQL query is being serialized here. It is not sent as it is to be serialized in some way, because it will be sent to the Docker or the database, right? So it is serialized in a binary protocol, and after it is being serialized over the pulled connection, it is being sent to Docker. And once it is being sent there, the database receives the query, the row into the patient table under the partition key, which you have mentioned as a UUID or the patient ID, that confirms as a success. So the response again then flow back. Like once you are done, the response simply keep on flowing back from this level to this level onto the upper level. So this way it will just go, and then whoever was calling, it will be um, returned to them. So this is the very basic application flow that we are going to have in our application. Okay, now let's talk about how the whole application flow works. We are going to take you fully step by step, so that you understand like from where the dependencies are coming in, and which dependencies are very important while you are writing this code. So at first, the Spring Boot application, this annotation triggers the component scanning and the auto configuration, like which we already discussed in our very first video. And then the IOC container is being built by the Spring framework, and it will manage all the beans, that is all the core dependency graph of your application. So now in your pom.xml, if you see, you already have the things like the Spring Boot starter data Cassandra in your pom.xml. The Spring detects it and activates the Cassandra auto configuration. So we have this artifact ID, right? So this tells you that Cassandra auto configuration has to be there, and auto configuration then reads some of the properties from application.yaml file. Like application.yaml file actually tells what would be the key space name. For example, the database that we started, what is the key space name for that, what is the data center name, and also where it should be contacting you. Remember, like we started our application in the 9042 when we were looking into our Docker Compose. Okay, so this is how these two guys actually talk to each other or comes together by telling that hey man, if you have a application like 127.0.01 is a loopback IP, right? If you have an application running in your loopback IP, make sure that in the port of 9042 you are um, trying to hit while creating your configuration. So in the pom.xml, based on our Cassandra uh, based on our Cassandra artifact, Spring detects it and it will activate it. And auto configurer, it will read that particular settings from that application YAML, like the contact points, the key space name and stuff. But Cassandra require one critical setting there. If you remember, we have been talking for multiple time, that is the local data center. So what this local data center is, so it has to get the local data center again from here. That is only one of the catch you have to understand here. So this is in the documentation how Cassandra session initializer and the Cassandra config work together. You see here also in the local data center, we have mentioned all these things. So this is a very essential step and do not miss if you are using Cassandra. If you are using any other database like MongoDB and the other stuff, take help of the documentations or the any LLM like Gemini or ChatGPT to make sure that you have all these configurations in place. So now what would happen is Spring would combine your customizer with the auto configure builder to create a fully initialized SQL session. So over there, that with this particular config with the session initializer, Spring would create your SQL live connection to your Dockerized Cassandra instance. So right now what we have is the moment we do a Docker compose and we start our application, Spring will be able to create a session connection pool towards your Dockerized container. And with the session ready, then Spring again scans for the repository interfaces. So like it goes with the scanning for the other interfaces after that. Okay, after it creates the basic connection to your Cassandra. And next, the Cassandra initializer, the session initializer, it has a component, right? So you see this component is there, it starts up, it waits for any application ready event and then runs a quick test query to ensure that whether it actually works or not. So those testing test queries and whether the health is really good about the connection, everything is being done by this guy. And this is all kind of a documented steps what we need to follow to use Cassandra in our Spring application. And in the finally, what would happen is once this whole process is done, the patient controller is created and the Spring injects all the repositories that are needed into the patient controller. So over there in the patient controller, you might see that we have patient repository and the medical event repository. Then as we discussed in our very first video, all the beans are getting ready, they are being scanned and then they are being injected by a certain dependency graph that is being placed. So now let me run the application. So if you are using Visual Studio, you can very easily do this run and debug. So let's do it and see what would happen. So over there you can see the application is getting started up. So the application started successfully, and if I go through the log, I can see like all my Apache dependencies, like the Cassandra dependencies, the Java driver, the DAX, everything is being done, and you can see like there is a even it is checking like whether uh, the table is there or not. All the basic things it has tested, and the Spring Boot, the default embedded server port is 8080. So it has already started in the port of 8080. So let's see our port. So I'm going to go over there and just hit. So tada, you see that in our localhost 8080 we have our Swagger endpoints running, and from there we can start sending the requests and we can start testing whatever works. So I think in our last video also we explained a little bit about Swagger, and it is very important guys to understand about it. Now, suppose here I want to try it out, and I'm just removing the patient ID because patient ID, it is expected that will be created by itself. Suppose I am naming a patient as S. Roy. Okay, the date of birth, suppose we are giving as 2010. The blood type is something like O plus, and the email is asb@email.com, something like that we have done. So let's see how it works. Okay, so now this is the basic curl that has been generated, and this is the server response that we got, that with this given patient ID it is being generated. Okay, so if you see over here, like all these annotations we have, like create a patients, so it is basically coming from here. So we are defining the mapping. We are like, it is going to be a HTTP post request as a post mapping. What is the operation it is going to have, like create a new patient and store in Cassandra. You see all these details are coming over there, and we just documented it well so that you understand it very clearly. And the response code also we specified that these are the two basic responses, that valid responses that we are going to accept. If it is coming as 201, that means the patient created successfully. If it is 400, then it means that in the model state is invalid in some way. And there can be other errors like the 500 and the 5xx family of errors that might come, that would be like not exactly controlled by us, but suppose the server in some way throws some sort of a exception. So what would happen over there is, the moment the request comes, our HTTP Spring uses Jackson's HTTP message converter, right? So it would convert the JSON into a patient Java object, and no manual like no manual parsing, nothing will be required over here. So that JSON that is being we have passed over there, okay, so that JSON will be converted to a manual I mean without manual intervention, a patient object. And after that you see one UUID needs to be generated, like if I'm not passing any UUID, this is kind of a very unique check we generally put in all of our application, that if like the front end is not sending any unique ID, that unique ID will be set by us. So in case that unique ID is null, it will be set by us, and then the mapping converter will kick in. So we are calling patient repository dot save, and if I go there, go into this save method, we will see that it is basically being it is extended from this CRUD repository that we have. So what it is doing behind the scene, so this is under the hood. Cassandra template uses this mapping Cassandra converter to inspect your patients table. From where does it getting the patient tables? So here in my domain, I have specified both of this table. So one is the patient table and another one is the medical event table. So over here, you see all these details I have given, like the if the string is coming as a patient name, map it to a column of the this patient underscore name. If the data is coming as date of birth, so there is something called uh, of a local date type it is going to be, and we are going to mark it for date underscore of underscore birth. So all this kind of a templating, by inspecting our table.patients annotations and the field mapping, it is going to translate the Java field like the date of birth or a local date into a Cassandra columns. Okay, then what would happen is, after this save is being done into the patient repository, like if I go to the repository of patients, a very important thing is that all the save, the inherited methods from the CRUD repository, you see all these things are uh, kind of implemented automatically, so you do not have to do anything. Like if you are passing anything like just the patient, it will be saved automatically, and it is also a upsert, that is either it update or it inserts. So all these things will happen in this manner. You can find by id, you can find all, you can do a count, or you can do a delete by id. Everything will be done over there. So at this level only the SQL or Cassandra query language preparation happens, and then it probably gets into something like behind the scene. If you are doing this save, something like insert into patients with some given values, it will be there. And then again internally all of these things happens by Cassandra itself. The DataStax Java driver uses the codec registry to map the Java type to the Cassandra where format. Like when we are sending it to the right now it is the basic UUID which we generated in the Java, right? So this particular object, like we have set a UUID, how it will be converted into a Cassandra QL, like the SQL UUID, all these things are being taken by the DataStax Java driver that we talked earlier, and then it is being handled automatically by it. I do not have to do anything, and the driver sends the bound statement to Cassandra via binary protocol over the port 9042 that we defined, and then uh, the data center and everything, all the other details also we mentioned, right? So over there in my Docker container, this thing got executed and then it came back. So now you remember this is the particular UUID that got generated. So suppose I just want to see where exactly this data is. So I can do a Docker exec. So when we say Docker exec, what we can do is we can just go inside our Docker and we can run our queries over there. So it is a bit offbit, but still I will show you what we are doing. We are going to do Docker. We will go inside into our Docker exec, and this is again a documented way to run any kind of query of your Cassandra QL on this. For example, here what we are saying is you use the hospital system. The hospital system is the one that we have mentioned in our application YAML as our key space. So over there you run this particular query. So let's see what output it gives. If I run it, you see that particular patient name S Roy, the email that we have given, all these details are coming over there. So the data that we wanted to insert, it got inserted successfully. Now let's take another data and we are going to just walk through completely. Okay, before that, like I also wanted to show you that we can do just a select star from. So you see like there is couple of but one more other patient also I have inserted, and it is kind of being reflected over there. Okay, so without further ado, I just made some basic changes into the patient name, and let's try to debug it through the application. Before that, you just saw it through my words, like what exactly is happening and how the data is inserted. Now let's see step by step what is happening into the application. So I have already started executing it just to save ourselves a little time. And now if I go into my application, I can see that there is this patient object that I just passed over there. You can see sroy2. Previously I just did a sroy and now it is a sroy2. This patient object we got. And like in case we are getting a null over there, what is this logic would do is it is going to just get a patient ID. So now in the patient object, if you see, there is a certain UUID is also being generated. Like if I just inspect this one, you see there is a certain UUID that is being marked into this, and you do not have to worry about the this list and the most significant bits, all these things. Now let's see what happens into the save. You will see that the saved patient is coming back and it is giving us certain HTTP status as created, and it is going to response like I just did step into this. But yeah, anyway, so the response that you see over there, it will be passed on to the application. So it is a overall, if I see, it's a very standard process, like how the data is being saved and how it is going to go into the repository and all the default things that are being written. So it didn't go anywhere because the save, if I see, save is being marked into like a method which is to be extended into this, right? But the important thing is like all the mapping of the Cassandra objects to the to the table objects, from the Java object to the Cassandra table objects, and then those table objects are being converted and sent over the wires. Everything is being done by the framework itself. So framework does all the heavy lifting for us, and you can see how important it is to still understand the internals of it, because if we don't understand the internals, we will not be even able to debug through what exactly is happening, right? So there are few other things that I wanted to mention which I kind of skipped purposefully. So one thing is about the tables that we created. So this is the patients table, and this UUID, primary key, or the patient name, all these things we are already defining here. And when we were talking about the domain, in the domain, we have mentioned that if it is a column, make it a this particular object. So this is one of the manual schema.sql that we have. This is being run by the Docker. So you can run this thing manually through your Docker execution, and all of your tables will be created. So that is why this thing is in place. And we also have that Spring, the schema action as a create if not exist in our application YAML, right? So this is the schema action. So what it would do is it will auto generate the create table SQL statement based on your Java entity annotation. So this do it completely behind the scene. In case you do not want to do that, you can use the schema.sql and you can run it via Docker, and just do a Google search how you can run it. So that's the application that I wanted you to understand end to end. So now that you understood the Cassandra, now the next step would be to understand some things regarding the MongoDB fundamentals, but I would want you to self-learn this. So you have actually seen how we have understood Cassandra from top to bottom, right? At first we took that why Cassandra is required, and how exactly the data is being modeled in Cassandra. So I will give you some basic hints around MongoDB. Then we are going to then we are going to give you a take home assignment, which if you implement, you will understand both how exactly with any kind of NoSQL database you can work. So what MongoDB does is it's a document oriented database. So when I say document oriented, that means you can just store the data in a flexible JSON like documents, or even the bson format or the binary object oriented notations are there. Okay, so in case of MongoDB, just any object that we are looking at, it will be something like this. The complete object, instead of different tables, they are being stored in this way. So let me just copy paste the document example I have. Yeah, in this way. So you can see this is a patient record, and a- all the information of the patient, like all the medical history, all the appointments that he had, everything will come under a single document. So if you see, this is the medical history, this is whether he has insurance or not, this is her contact information, and all the date of birth, everything comes under a single everything a single object. And so what is the advantage of it and why it became so popular? uh, so let's tackle this checkpoint question. You will understand it, that what is the difference if I have to store the allergy in a different array in a MongoDB, or in a separate patient allergies table with a foreign keys in SQL Server? What is the difference between that and storing everything over here in a single record? The difference is simple, guys. Like the one of the basic the data storing fundamentals is locality and performance. So MongoDB stores all the allergies in the same document. One read gets everything. So SQL Server requires like the join access the two tables. Suppose the moment I go into the patient allergies, what would happen is there will be two different tables I have to join, and then I have to further build my query. And there is a trade-off as well. MongoDB duplicates the allergy data if the same allergy appears for the multiple patients. So suppose there is a certain allergy ID you have that you cannot really reuse in case of it is a MongoDB, because you have to keep on copying the data. So the trade-off is it comes with a cost of duplicacy of the data. Okay, so it comes with the cost of the duplicacy of the data, and I hope sorry, the duplicity of the data. And I hope you understand this part, that the moment I am keep on storing every single record over here under the medical history, or under the under the same document, all the medical history, allergies and whatnot, that moment it becomes a certain duplicacy. So for the other, like had it been the SQL Server, what would have been our advantage? Like we could have simply put things like a allergy table, and with a allergy ID. So every patient who has this allergy, they might have this allergy ID, or for hypertension ID. But here though we have to write everything in a separate manner. There is no scope of joining. And one of the very practical example is like when you have like a very moving sort of a data. Like have you seen when in Instagram or your Twitter, when the hashtags are getting populated? So it's a ever increasing list, right? Like if for an image you can keep on giving some random hashtags. So in that case, this sort of like a little uh, randomized structure actually helps. And you can just keep on adding field, like tomorrow suppose there is a photo, you want to add a location, and the next day you decide that okay, only for this country, for some reason they are not allowing you to put the locations. So in that case you can just take it away from that particular document. You are not even storing it. So this sort of things, it gives you a lot of flexibility. Plus MongoDB is definitely a very popular one, and it like when we are talking about the MongoDB, it being a NoSQL, it supports ACID as well. So if you mark something as a transactional, it will do as a singular transaction. So there are so many other details like the ACID, indexing, everything it supports. And what I would want you to do is, I would want you to have in your mind a basic difference between the MongoDB and Cassandra. So MongoDB is definitely like a, as we said, like it's a document, whereas Cassandra was a white column database. Again, not a columnar, it's a white column database. So but the schema, from the schema part, the MongoDB is completely flexible, right? And from the Cassandra part, it is a fixed sort of a thing, and consistency is very strong. And it is kind of a like when the different data structure works, it becomes eventually consistent. And for the query flexibility, it is very rich. And the MongoDB, like you can do a lot of aggregation pipelines and stuff, and in the Cassandra it is a bit limited. And when you have a complex object and the hierarchical data, the MongoDB is best. And for the time series data, Cassandra is good. Like, although we used Cassandra for our application just to show you one of the case, but generally Cassandra shines in the time series database and very high rate or very high throughput scenarios. Okay, so that's the video, guys. Like, this is the basic things that for the MongoDB I covered, and what I want you to do is create a create the similar application. Okay, create the similar application in Java Spring Boot using MongoDB. And the moment you understand this, like any kind of NoSQL database, you will be able to onboard into your application, and you will also get the idea that when to use what, like when to go for the relational database systems, when exactly we should be going for the document database, or when exactly we should be going for the Cassandra. Like very honestly, like the examples that we took up earlier, the for our dashboard, it is not exactly a Cassandra use case, but I wanted to explain to you using Cassandra, because many people I have seen, although Cassandra is such a great database, but they kind of take a step back because the initial implementation is a bit difficult to understand. So uh, please implement this, and let me know in the comments in case you have any doubt. I will try my level best to answer them. Thanks a lot. See you in my next video. Till then, stay awesome. Bye.